Good day everyone. So here we have a helium gas that is heated first at a constant volume and then it expanded at a constant pressure. So we have here two stages or two processes. So state 1, we had a P1, T1. This has gone to state 2 at a constant pressure. This means that V2 equals to V1. We have a temperature T2 of 500 Kelvin. This is 300 Kelvin and 100 kilopascal. So the first process occurred at volume constant. Now the process continues and the volume now tripled at a constant pressure. So state number 3, volume 3 equals to 3 times volume 2 or 3 times volume 1. And remember that it says constant pressure, so P3 equals to P2. In order to visualize the process, let's draw the PV diagram. So we started at some point somewhere, and then we have increased the temperature at the same volume. So we have gone maybe from state 1 to state 2 at a constant volume. Then we have expanded. That means we have increased the volume 3 times now, the initial volume. So state number 3 at a constant pressure, somehow here, where the volume here is 3 times the initial volume or the specific volume. So the total work can be written as work from 1 to 3 is the work done or added between 1 and 2 plus the work produced between 2 and 3. Now since the volume is constant between 1 and 2, the work here is 0. So the work, the total work, in fact, is the work between 2 and 3. Remember, the work is the area shown here in gray color, which is now equals to, since the pressure is constant, P2 equal to P3, variation of volumes between 3 and 2. But because we are dealing with a specific work, we can express this in small letter as pressure to specific volume 3 minus specific volume 2. Remember, since helium can be considered as an ideal gas, we can write this as helium constant into temperature 3 minus temperature in state 2. So here we will take R for helium as 2.0771 kilojoule per kilogram Kelvin. So now we know that we need to find the specific work, and the specific work can be expressed as the work done between state 2 and 3, because the volume between 1 and 2 is constant. That's why the work between 1 and 2 is 0. So we have the R values. We have the temperature in state 2, which is 500 Kelvin. we need to find temperature in state number 3. Pause the video and think about it. Now, since this is an ideal gas, we can use the following relation. We can also use the same relation for the third state. Taking the ratio of those, we also know that the volume in state 3 is 3 times that of volume in state 2. So we can write temperature which is equal to 3 times temperature in state 2 equals to 1500 Kelvin. Now we can substitute straight away with the relation we found earlier for work between state 1 and 3. So, specific work equals to the R constant T3 minus T2 So, this is the work produced as a result of this expansion.